My name is Grace Lamb. This is my Physics 2211 Lab 4 on oscillations. So for a brief introduction, the purpose of this lab is to analyze the motion of a spring mass system which is oscillating as well as swinging in an arc shape. In order to accomplish the goal, Tracker will be used in order to analyze the observed motion of the system. With the data collected from Tracker and using the fundamental principles of Newton's second law as well as the energy principles, a glow strip probe will be manipulated in order to make a comparison between the observed and computational models. Through this comparison, it can be determined whether or not the system follows the energy principles. A brief preview of these results is that the energy principles is follows as the total change in energy of the system is equal to 0. And the assumptions in this lab is that the system and surroundings are defined as indicated below, and there are no additional forces that would add work to the system and change the total energy. And as mentioned, the system is the mass, spring in the earth, and the surroundings is nothing. Then moving on to the fundamental principles. The first fundamental principles is Newton's second law that says that F net is equal to the change in momentum over the change in time. And in this case, F net is going to be equal to the force of gravity plus the force of the spring force, as shown in the force diagram. So F net is going to be equal to negative k times the length, the magnitude of the length minus the relaxed length times L hat minus mg in the y direction. Then from this, we're able to get a velocity update formula as well as a position update formula that will be used later. Then the second fundamental principle is the energy principle, and this states that the change in the energy of the system is going to be equal to the work of the surroundings plus the change in heat. And in this case, the system is the mass, spring, and the earth, and there's no surroundings, so the change in the system is going to be equal to 0. So the overall change in energy of the system is going to be equal to the kinetic energy plus the potential energy plus the spring energy, and it's the spring potential, which is shown there. And then for a quick little procedure, the video will be uploaded to Tracker, where the Tracker data will be manipulated in order to get the observed motion data, and then the glow strip probe will be edited using the observed motion data as well as using the fundamental principles, and this will allow for a comparison to be made between the computational and observed motions, and then we're able to determine error and then determine if the energy principle is satisfied and the different oscillation periods. So starting off with the observed motion in Tracker, we were given a video as well as given the mass of the thing that it was swinging, as well as the magnitude of L as well as L naught and the spring constant. And then from this, we were able to calibrate the initial starting point to 0.7 meters. And from this, I was able to import all of my information into Tracker and was able to get the initial starting point as negative 1.22, negative 0.635, 0 meters, and then for me the initial velocity is going to be equal to 0, so I was able to find all these initial conditions. I was able to do this by using point mass on Tracker and was able to get the point mass at all the different delta t. And once I got all this data from Tracker, I was able to edit the glow script model. So the first thing I did was set up all of the initial conditions. So I took the mass of the ball that was given, as well as the position vector that I found to be the initial position and the initial velocity, as well as the L naught, the spring constant, and then the overall gravitational constant. Then once I did this, I used the fundamental principles that I explained at the beginning of the video, and I updated the spring force as well as the delta E system. So then I was able to input the change in overall energy by putting in the kinetic energy, the potential for gravitational, and the potential for the spring. Then I was able to input the F net by putting in the force of the gravity as well as the force of the spring, and then I used the position update formula and velocity update formulas as well as the energy principles in order to further update the computational model in GlowScript. Once all the code was updated, I was able to make a projection of the observed versus computational models. So as seen all the way to the right, the position versus time graph of the model is going to be the blue, and then the experimental data that I found is in the red. So obviously you see that they're very, very similar. However, there is kind of differentiation, and this could come from possible error. So I determined that the error could be that the systems may have had work done on it, and it's not just an isolated system. And then obviously human error from Tracker, because I had to use point mass in order to do this, so locating the center of mass. Overall, the computational model did a great job of reflecting the observed motion that was shown. For what does this mean? First, does the model follow the energy principle? And yes, the energy principle is satisfied as the total change in energy is equal to 0. And this is because there are no external forces acting on the system and the surroundings. And even though there are all different sums of different energies, they will all sum out to be 0. And this is shown as the delta UG perfectly is able to cancel out the delta US, and they're able to cancel each other out so that the overall change in energy is going to be equal to 0. So then it was asked to make two separate estimates of the oscillation periods, first by estimating the oscillation period of the x position data, then the y position data. So I did this by just taking 3 periods of the x position and finding the average of that, and then 3 periods of the y position and finding the average of that. And as you can see, the x direction has a higher time for the period. And basically this just means that different directions cause different deviations, and this affects the spring constant in the graphs. So basically it takes longer for the x direction to make one full oscillation. And thank you so much.